using inverse trig to find our angles. So going backwards, we're finding angle measures is what we're doing here. So this is kind of the last part of section 5.3. So we're going through and finding angles. When we're going backwards, that's kind of in reverse. That means inverse, right? So we have these our trig functions, sine inverse of our x, or of our basically of the fraction, right? Of sine would be opposite over hypotenuse. And we have cosine inverse of whatever my fraction is, and then I have tan inverse of whatever my fraction is, right? Adjacent over hypotenuse, and then opposite over adjacent, and then you have the reciprocals as well. So inverse allows us to find the angle, the measure of the angle. So usually you'll see like this, sine inverse of x, and x just represents what this is right here, our answer. So if we do sine inverse, so I have to hit shift sine, and this will pop up like that, and then I can hit in my decimal or my fraction or whatever it is here, the answer, that ratio, and I can enter that, and then it will produce my angle. So approximately it's going to be 75 degrees, right? So that's close to 75 degrees, rounded it there. Same thing with this. Secant's a little bit different, right? Because remember, secant of theta is equal to 1 over cosine of theta. So if I want inverse secant, if I want that angle, what I'm going to have to do is type in, to find cosine of theta would be 1 over my answer, right? So that'd be 1 over 1.0545829. So then I'm typing into my calculator. Now I can type the inverse of this. So the inverse of cosine is 1 over my answer, right, to find my angle, 0.545, and so on, right? So I'm going to type that in my calculator, and I get my angle is equal to approximately, we'll say 19 degrees. So it's approximately 19 degrees there. So basically that secant one's a little tricky, because secant of theta equals 1 over cosine of theta. And if secant of theta equaled the point, or 1.0545829, then 1 over 1.0545829 would equal cosine of theta, right? Because I would just flip this fraction, because this fraction is flipped, right? So if I have secant, I can flip it, right, and it equals cosine. So if I take this and I flip it, that would equal cosine of theta. And then I can do the inverse of that. So that's how you do that one. And then here's another example. Oops. So we want to find the angle measures given in interval. So here's our interval. So that's where we want our answers, in between 0 and 360. And we want to find what is the angle if our answer is negative root 2 over 2. So what we can do here is we can open up and say, since our answer is negative, that means we're in either the second quadrant or the third quadrant, correct? So we're in one of these two angles, and we can see from our list of our table that we get answers for cosine of root 2 over 2 when our angle is 45, right? So we're checking that chart from a couple videos ago. So our angle of 45 produces a root 2 over 2, but it's negative, so we're in the second or third quadrant. So we could use this as a reference angle. So we could use that as a reference angle. And we can go up 45 degrees, and we can go down 45 degrees from 180. So if I take 180 and subtract 45, I'm going to get 135. And if I add 180, I'm going to get 225. So those are my two possible answers from 0 to 360, is 135 and 225. So now here's an application problem. You're looking at grade resistance. So driving on an uphill slant or downhill slant, we have this force in pounds with grade resistance, and it's this formula. Force is equal to W, which is weight of the automobile, and then times sine of theta, where theta is, if it's positive, then we're going uphill. Okay, then we're driving uphill. If theta is negative, then we're driving downhill. Okay, so we're driving downhill. So that's if theta is negative. Okay, so let's go ahead and figure this out for what if the weight of the car is equal to 2,500 pounds and the angle is 2.5 degrees. Well, then we just find our force by taking 2,500 and multiplying that by sine of 2.5, which is approximately 110 pounds of force. Okay, then there's another problem. Okay, well, what if W is 5,000 pounds and the angle is negative 0.61 degrees? Oops, 6.1 degrees. Well, we can just take our force is going to be equal to 5,000 times sine of negative 6.1. And that gives us approximate force of negative 530 pounds, which that just means we're going downhill at a force of 530 pounds. And then lastly, okay, what about for 0, angle of 0 degrees and an angle of 90 degrees? What would that be? So that would be traveling flat. What's the force going flat? What's the grade resistance going flat? And what's the grade resistance of going uphill? Well, here we go. So force is equal to our weight times sine of 0, and force equals weight times sine of 90. Well, sine of 0 is 1, right? And so it's just the force would equal W here. And this one, sine of 90 is 0, so your force would be 0. So you'd have no gradient resistant force there, and your force, if you're going straight horizontal, then it would just be the weight of the car. Okay, so that's it for the examples. Here, so on page 512, you could do these numbers: 141, 143, and 127, 117, and 121. So let's go ahead and do these ones. Okay, so here we go. Here's 117. We're trying to find the angle. So the angle is equal to, since we're doing sine, we do sine inverse of our answer, and that will give us, so we plug this into the calculator, and that will give us our answer of approximately, our angle will be about 16 degrees. All right, and then on number 121, we're finding secant, so same as the example that we did. So try to do this one on your own. Okay, so here we're finding our angle. This time we got to take cosine inverse of 1 over that answer, right? Because secant is the reciprocal of cosine, so we have to flip our answer. Okay, so we put that in our calculator, and we get the angle is approximately 69 degrees. So there's that one. And you can go ahead and practice the other ones. You can do those other ones on your own.